Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from group 7, subject numerical method. Will present designing bridge for eigenvalue and eigenvector. So for the part introduction, I will pass to the Abdi Karim to present their part.
Thank you, Mohammed. I'm Abdi Karim. I want to present for the introduction part. So here we go. Eigenvalue and eigenvector are important mathematical concepts that arise in the study of linear algebra and its applications. An eigenvalue, also known as a characteristic value, is a scalar that represents a specific property of a linear transformation. On the other hand, an eigenvector, also known as the characteristic factor, is a non-zero factor that, when transformed by the same linear transformation, results in a scalar version of itself. These concepts are used to diagonalize matrices, understand the stability of dynamical system, and in a variety of other applications. The eigenvector of matrix from the basis of the eigenspace, which is the subspace spanned by the eigenvectors. The eigenvalue and eigenvector pair are closely related to the concepts of eigenbasis, which is a set of eigenvectors that form a basis from the space on which the linear transformation acts. Eigenvalue and eigenvector are important concepts in the design of bridges. They are used to analyze the dynamic behavior of bridges, specifically the natural frequency and modes of operation. So thank you, and that's all.
Okay, next for the part real world problem will present by me, which is Muhammad Ikun Zakim bin Muhammad Azmi. Okay, next. So a real world problem refer to a problem or issue that exists in the everyday practical world as opposed to a hypothetical or academic situation. So this is example real world problem for eigenvalue and eigenvector, which is designing bridge, designing car stereo system, communication system, and mechanical vibration. So from list real world problem above, our group choose designing bridge as our study case. So in this assignment, we need to use eigenvalue and eigenvector method to conduct our calculation. So I will
Okay.
present to the n.syhira.
Second is method of assessment will be presented by me. Referring to our current problem, the method that is suitable in order to solve the problem is by using the eigenvalue and eigenvector. A linear system of equations or a matrix of equations is related to a particular collection of scalars known as eigenvalues. Eigenvalues are also referred to as characteristic roots, characteristic values, suitable values, and hidden roots. The symbol for this eigenvalue is lambda. While an eigenvector of a linear transformation is a non-zero vector that changes by a scalar maximum when that linear transformation is applied to it. Furthermore, these eigenvectors are designed as B. To solve an eigenvalue and eigenvector problem, we should use the characteristic equation to find the designated eigenvalue and eigenvector. So we can start from the Hooke's law, F equal to Kx. Then we use Newton's second law, F equal to ma. Combining both, we have the equation there. Then amplitude, velocity, and acceleration, we can express them. Then substitute back to the equation of motion, we will produce this formula. When we simplify, we get this by using matrices. Then we let lambda equals to omega square, where omega square is natural frequency. From the equation above, step by step, we can know that the lambda is the eigenvalue, v is the eigenvector, and a minus lambda I equal to 0 is the characteristic equation. The question is asking two masses coupled, three spring without damping. Uh, estimate the develop the characteristic equation of the vibrating system. find the eigenvalue and corresponding eigenvector of the system, determine the natural frequencies of the system, draw the mode shape corresponding to each natural frequency, then validate answer using Freeman. Okay, that's all. I will pass to Iftika, Beros Nizam and Najmi Fidaus.
Okay, so I'm Iftikar and Muhammad Nazmi will present about calculation, result and discussion. Okay, next. Okay, firstly we do the equation of motion. So for F1 we got M1 x double dot 1 plus plus K1 x1 minus K2 x1 equal to 0. And for F2 we got M2 x double dot 2 plus K2 x2 minus x1 and negative K3 x3 equal to 0. Next, we do the matrix form. Okay, we use the formula matrix M matrix X double dot plus matrix A matrix X equal to 0 and we got that answer. Okay, so after that we assume the harmonic motion. So we got X equal to V sine omega t, X single dot equal to omega V cos omega t and X double dot we got negative omega r square sine omega t. So after that we do the char- characteristic equation and we use the formula matrix A minus lambda matrix I and times matrix V equal to 0. So we got the eigenvalue for lambda 1 equal to 5.372288 and eigenvalue for lambda 2 we got negative 0.37228. Okay, so next we do the natural frequency. Lambda equal to omega square. So for omega 1 we got 2.3176. For the omega 2 we got
Mi, pakai quality tingkat-tingkatkan sikit.
0.315. Uh, After that we got the integrator 1 equal to 1 and integrator 2 0.4387. And for integrator 2 we got 1 so we make solution. So the answer is 3. So next. So now I pass to Najmi.
Okay, thank you, Iftikar. So this is our discussion. Based on the result that we obtained, the value of eigenvalue, eigenvector, and natural frequency can be noticed in this table. So this our final result. Eigenvalue 1 equal to 5.37228 and the eigenvector V1 equal to 1, V2 equal to negative 0.843007 and the natural frequency is 2.31782 and eigenvalue 2 equal to negative 0.37228. Eigenvector for V1 equal to 1 and V2 equal to 0.59307 and the natural frequency is 0.1015. A component distortion when vibrating at its native frequency is known as its mode shape. In structure dynamic, the phase mode shape and natural vibration shape are employed. The deformation that a component will exhibit when vibrating at its native frequency is described by its mode shape. The mode shape of an eigenvector is a visual representation of the direction and magnitude of particular vibrational mode of system. So the eigenvector will indicate the direction of movement, while the eigenvalue will indicate the magnitude of the movement. For lambda 1 and lambda 2, the mode shape is directly proportional until the value reach 1 and then inversely proportional until certain value. Say that's all for me. So I pass to the Abi Karim.
Thank you, Najm. I want to present for the conclusion part. So, engine value and engine vector are important concepts in the designing bridge because they can be used to determine the natural frequency and modes of vibration of the structure. The natural frequency of a bridge are the frequencies at the which the bridge will vibrate when excited by a force, such as a wind or a passing train. The modes of vibration are the different shapes that the bridge can take when it vibrates on a particular frequency. When designing a bridge, it is important to ensure that the natural frequencies of the bridge are not close to any of the frequencies at which the bridge will be excited, as this could lead to resonance and potentially dangerous vibrations. One way to do this is to use eigenvalue analysis to calculate the natural frequency of the bridge and convert them to the frequency of the expected excitations. In addition, eigenvector can be used to determine the modes of vibration of the bridge and to identify which parts of the bridge are most flexible and which are most rigid. In summary, eigenvalue and eigenvector analysis is an essential tool in the bridge design, as it can be used to determine the natural frequency and modes of vibration of a structure, and to design the bridge to be more stable, safe, and cost-effective. So, can you go for the reference, please? Uh, from the resources. Point one, we got the resource. We refer for the link kicks 22 February 17 application of agent value and agent factor. The second one is Srati, fee. 2018-26 real world problem solving frontiers retrieved January 25, 2023. The third one, we also refer applications of agent value and agent vector in design, share and discover knowledge of SlideShare. Also, the fourth one, we refer Sharma, common chair.n 2004 numerical method for engineers and scientists. Alpha Science and Ltd. The fifth one, we refer Tagan, care. 2019 December 2015 dot agent value and agent factor medium retrieved January 25, 2023. So that's all from the resources, and thank you.
Okay, I think that's all for our group, and thank you.